So I'm going to be revising some stuff with arrays and lists today, because we had a little bit of a problem with the video. We might not get through all of it today. What I want to do is show you. So this is the grow flowers thing from a couple of shoots ago, where we made a bunch of flowers grow. Now aren't they very pretty? And so I've got a copy of my script. We sorted it out. It was the one of this was dead.
Cool.
Thanks. Sure. No worries. Presume that he was the technical guy. So I've got my code here for doing that. And I put that up. You'll be looking at that in today's tute. What we're going to do, because Unity 3 now gives us the option to use the debugger and to actually step through our code, I'm going to show you how to do that. So, and then we're going to look at we're going to watch this code execute line by line, because I think it's informative to see how it's doing that. So what we need to do in order to set that up is, first of all, in Unity, so first of all we need Unity 3, right? This won't work with your old Unity 2.6. In preferences, there's an external script editor option. Now normally that would probably be set to use built-in editor Unitron, which is the one that you're probably familiar with using. But you can select whatever editor you want, and in particular there's a browse option here for you to go looking for an editor. And I don't know how you do this on Windows, but on the Mac, if you go find the Unity folder, which has Unity 3 in it, inside there's this app called MonoDevelop. And MonoDevelop is a more sophisticated programming editor, much more sophisticated than Unitron. And it includes a debugger. And so changing that to MonoDevelop, now when we open up our script, rather than where before it ran, it opened up in Unitron, now it opens up in this, which is the MonoDevelop editor. And the MonoDevelop editor has a whole bunch of features that I'm not going to go into, some of which I find a little bit annoying, which is why I don't usually use it as an editor. Although probably you can configure some of it away if you play with the preferences. But the nice thing that it has is the ability to actually step through our code. So there's the flowers script. I wonder if I can change the font size. Let me see. I don't know how to do this. Here we go. Text editor, general. Maybe, no, text editor. You think there would be an option here somewhere for font size? You reckon? Maybe not. That would be annoying. Surely there should be an visual style. No. Task is blah 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 blah. Okay. Wow. Doesn't seem to be an option for setting the font size. That is annoying. View. Format. No? Anyone see an option anywhere for changing? Oh, come on. Debug Windows Buildbars. Everything except for, what's zoom in do? That kind of works, okay. Not really what. You think there'd be an option for it. Okay, anyway. We'll just zoom in, that'll do what we want. Does it need to be bigger? How's that for readable? Can you see that? Can you fall further back? Okay, getting general nods. Okay, so there we can see our code. That's a weird way of doing that, but never mind. So I mean, if you want to use this as an editor, it has some interesting things for that. In particular, one of the sort of both nice and annoying features that it has is that if I do something like, so I have a variable here called best height. If I start typing that, if I press B, as soon as I start typing, it suggests a whole bunch of things that I might want to type. And I can, instead of actually typing the whole variable name, I can search through this list, and wow, it isn't there. That's not what you want to choose. Oh wait, no, it isn't there. Anyway, it usually suggests, as you start typing, it suggests things that you might want to be typing. In this case, it's not intelligent enough to know the best height is something that I might want to be typing. But if I say, let's see if it works in this context. No. Shortest dot. So, I mean, this is nice. So I typed shortest, press the dot, which means some field or method of it, and now it gives me a list of all the fields that I might want to look for. So I can actually search through this list and find all the different things that are attached to my object, and I can find transform, and I can press dot again, and it gives me a list of all the fields of transform. So I can search through transform and find local scale and so forth. And so it's kind of useful in that it knows, it basically knows what objects are and what fields they have and can suggest them to you if you want. The annoying thing is that I find it suggests things when I totally don't want it to. So, for example, at the moment if I do for var I, as soon as I press space, it instantly fills in the fact that the first suggestion it gives me is if, and if I press space, it accepts that suggestion, and I don't want the word if, I wanted I. So I don't know how to actually turn that off. Most of these systems only do suggest when you actually ask it to suggest rather than automatically. So that's a little bit annoying. Anyway, that's not important for it right now. What I want to show you is how we set up debugging. So first of all, once we've set the editor to monodevelop, the next thing we need to do in the assets menu, there's the sync monodevelop project at the bottom of that menu. So we go and select that, and that sets up, you're not going to see anything change in this case because I'd already synced it, but that sets it up so that monodevelop knows, basically knows about the code and where it is, and so that it can then run the debugger on it. You can't run the debugger. You can edit files without doing the sync, but you can't run the debugger without doing sync. So the first thing you've got to do is do that synchronization. Now, when you've done that, now there's an option up here. Whoops, not there. Up here at the top of the, at the top in the toolbar at the top here, there's a little button with a couple of cogs on it and a green tick, I think, or something. And if you hover over it, it says it's called debug. If we press this button, it connects monodevelop to Unity. So it starts if we wait a little moment, it actually starts a second version of Unity. So we've got, there's the old Unity window we had before, and there's the new Unity window that it's just opened. And so it's opened this project in a new Unity window. So if we find, let's turn off my anti-RSI thing. If we find, let me just turn that off permanently. Quit. If we open up the scene that we had, so there's the, all right, so we've got the flowers scene open. Now if we run, so we can run this separately in here. Now nothing interesting will happen if we run that there for the moment. So let's just hide that window for a second. So we could run that and it would run the program and it would run very slowly because it's running in the debugger. But what's interesting is the ability to actually do what's called setting breakpoints in the code. Setting a breakpoint in the code tells the debugger, when you get to this line, stop and let me see what you're doing. And so if we put, for example, set a breakpoint here at line 9, so set a breakpoint by clicking the mouse in this little grey bar on the left of the code, just before the line numbers, and it puts a big red dot in there. It highlights the line as being a breakpoint. We'll set another one down here in update as well. And so now, basically we're saying when the debugger is running the code, when we get to this line, stop and let me interact with the code. And the same when we get to this line down here, stop when we get to there, and also let me interact with the code. So now, if I go back and come to my second version of Unity here, if I press the play button, Now, actually, nothing will happen. And the reason why nothing is happening is that over here, we've stopped. Because the first thing, one of the first things that happens when we play a program is to run the start method on any objects in the scene. And so we're running this start method, and we've got to this breakpoint, and we've stopped. And the program isn't going to go any further until we tell it what to do. Now, up here on the right-hand side of the toolbar, there are 3 little buttons. If you hover over those, they're called step over, step into, and step out. Now, we're going to look at particularly at step over for the time being. Step into and step out are going inside methods and coming out of methods. But step over is just for stepping through the code one line at a time. And so if I press step over once, then it goes on to the next line of code. If I press it again, it goes on to the next line of code. And so we can step through that code, watching it execute. And it does each line, and does it however many times we had flowers. I think there were 4 flowers. And then it's done. And now it's finished running start. And the next thing that would happen is that it got here to this breakpoint in update, and so now it's going to run. Now it's going to show me this code, and so I can step through this code. So the nice thing here is you can actually, whereas before you had to just sort of, all you could see was the before and after. You could pause Unity in between. Well, you can't even pause Unity in the start. The start just happens as in one block. Now we can actually pause in the middle of start and step through this code and watch how it executes. So we could see this loop going round and round 4 times because there are 4 flowers in the scene. And if we wanted to, we could look at each of these lines and what it changed in the world. So the other thing that we have here, as well as being able to see what we're executing, down below that there's a window here called locals. And this shows all the variables that are currently in the code that we're looking at. So here in the update method, the variables are this, well, let me get onto the other ones first. This one's interesting. So the other variables, I don't know what that is. There's best height, which is this variable here that we've declared as best height. There's h, which is the variable we've declared down here. There's I, which is the loop variable. And there's shortest, which is the variable that we declared at the top. And so they're the 4 variables that are in this method. The other thing that we have here is this variable called this. The variable called this contains all the global variables. So if we open up that one, we can see a bunch of variables that, well, a base variable, I don't know what that is. But the important thing is the variables we have here up the top. Heights, flowers, flower, prefab, spacing, growth rate, they're all there in this variable. There's heights, flowers, growth rate, spacing, flower, prefab. So if we want to watch any of the variables that are global variables that are defined at the top of our script, then we have to look inside this. Any local variables will be listed down here below. So for the time being, we're only really interested in watching the local variables, so we don't really care about that. So now let's go back to our code. So the first thing, so what we're trying to do here is to find the shortest flower and then make that flower grow. So what we've got is a variable shortest, which is the shortest one that we've found so far, and a variable best height, which is the height of that shortest flower. And I'm saying initially there is no shortest flower, so initially shortest is equal to null, and initially, well, best height will be initially 0, because we didn't actually initialize it, but any float that we have created that doesn't have a value is going to be 0. So now as we step through the code, actually we can see down here, we step through that code, step over, we can see down here, okay, that's interesting. It says does not exist. That's weird. Wonder why it does that. Eventually, hopefully. Oh, that's really helpful. Does not exist in the context. That is not what I wanted to see. This worked when I did it at home. Huh. Great. Okay, so the debugger isn't perfect. What do you mean? Okay, let's try doing this. Nope, Nope. Oh, BKB, that's not good. Okay, I'm going to stop this and try it again just to see whether it works if we try it again. Always turn it off and turn it back on again is, you know, standard computer science magic. If something doesn't work, turn it off and turn it back on again. Okay, let's try this again. Play. Okay, we're at that break point. So the other thing we can do, which is worth knowing about, is if we don't want, I'm not really interested in this breakpoint at the moment, so rather than stepping through the code, I can press this button here, which was the debug button, but it's now changed to the continue button, continue the execution of the application. So that'll continue until the next breakpoint. So if I press continue, it just runs through the whole code until it reaches the next breakpoint, which was this one, the one that we're interested in. And now hopefully, why is this not working? This is not a good piece of software. Oh, that's the watch list. That's okay. Does not exist. What? In the current context. You're wrong. Great. I swear this worked. I tested this. Okay. Well, that's wonderful. Anyway, what should happen, hey, if it worked, what should happen is down here, where it lists all the variables, it should show you the values of the variables, and as we step through the code, you should be able to see the values of the variables change. But for some reason, Mono developers decided not to let us do that. Yay. Anyway, hopefully this will work better in the tutorials. If it doesn't, then, yeah, you know, brand new software doesn't always work. Oh well. In any case, if we go back and run this code again, at least we can see the behavior. Actually, let's run this again. Oop, oh, now everything's crashed. Woohoo! Oh, what a lovely day. Ignore. It's not my day today. Let's try doing this all over again. Open up that. Come on. What is that? Tidy up. So, anyone get up to anything fun on the weekend? I went to the Manly Jazz Festival. That was pretty cool, even though it rained. But you know. Here we go. Trying again. See, I got to see Mr. Percival. He's kind of fun. He does weird things with looping pedals and stuff. Ended up dancing on stage with him. It's pretty cool. And about 20 other people. It wasn't just me. You know, he didn't invite me up just because he liked the way I moved. But anyway, but I digress. Come on, run, you stupid thing. Hello, hello. Are you going to run? Yes. Waiting to connect. Let's try everything again. Press play. Go back over here. We press continue. We press step. Yeah, we're looking at the wrong thing. Look at that. Hey, we got it. Okay, cool. I don't know why, but now it works. That's great. So as I was saying, you can actually see the variables. So shortest is initially null. Best height is initially 0, and h we haven't set anything to yet. And I starts at 0 and counts to the number of flowers. If in doubt, start it all over again is the other lesson. So we step through, we're looking at flower number 0, and now we're going to get the height of flower number 0 and stick that in h. And so if we step over that piece of code, the variables go away. Yay! Oh, I'm having a good day. If we stepped over that and this worked, then here now we'd see that h contained the height of that flower. But, you know, that doesn't work. In this case, because it's the first time through the list, we have no shortest flower so far. So what I've done is put an if statement in here, which says if there's no shortest flower so far, then we just remember the current flower. So we remember flower 0. So shortest is equal to flower 0, best height is the height of flower 0, And you would be able to see that in the watch list if you could see these things. Let me, I wonder if this will work. Let me see. Can I view? No. No. Oh, no, no. 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 Anyway, whatever. Not working things. So now we go on to the next. We go on to the next flower. So the next value of I, we get the height of the next flower. The shortest is no longer null, and so we go to the else statement. And now we check whether the height we just got is less than the height of the shortest flower so far, which it wasn't, so it just went on to the next flower. And I think we're going to find that that flower is the shortest one. The first flower was the shortest one. Yep. And so we're going to go through each flower in turn, and the first flower we had, it was the shortest one all along. So we have found a shortest flower, so shortest is no longer null, and so we now this statement will make the flower grow. And so then we make that flower grow one step, and then it runs until it comes back to the update again, and now we can step through the code again and see whether there's a new shortest flower. Let me stop that and change the setup in here. Actually, let's do this. Let's run debug again. Start that all over again. Let's change the order of the heights of the flowers. So the heights of the flowers, the initial heights of the flowers are stored in here. So I said the initial heights were 0.01, 0.02, 0.03, and so forth. And so it was the shortest flower initially was element 0, it was 0.01. So I'm going to change that. I'm going to make that one 0.03, make that one 0.02, and make that one 0.03, and that one 0.01. All right, so the shortest one should now be flower number 3. So now if we run the code, we're not interested in that breakpoint. We can actually remove that breakpoint if we want. Let's click there and get rid of it. We'll continue. So now if we watch the code, watch those variables annoyingly disappear. So the first time through we remember flower 0 because it's the shortest one we've seen so far. The second time through we compare the height of flower 1 to that. Now flower 1 I said we had height, I've lost that. Oh, I can't actually even look at that at the moment. Flower 1 was actually shorter, and so this should be true. So because it's true, we now throw away we remember the shorter one instead, and so now we're now remembering flower 1, and we remember the height of flower 1 as whatever it is. And then we go around again. This time we're looking at flower 2. Flower 2 is not shorter than flower 1, so now we go around again, looking at flower 3. Flower 3 is shorter than flower 1, and so remember that is our shortest flower. Finally we look at flower 4, no, that's no good, and so the shortest one is flower 3, and the code makes flower 3 grow. So this would be a whole bunch nicer if we could actually watch the variables, but I don't know why this is wrong. Anyway, that's life for you. So still, it's useful in being able to step through your code and see what's going on. It's more useful when you can actually read the variables, but we won't go on about that. So what I want to just go over then, I was asked if I could sort of revise the stuff on lists. So I just, first of all, I want to remind you the difference between arrays and lists. Not on the screen. Arrays, so in Unity they're both called arrays, right? And what I'm calling arrays in Unity are called built-in arrays, and what I'm calling lists, it calls variable length arrays, or the array, capital A array class. I'm going to call them arrays and lists because that's just the normal name, but remember Unity docs give them annoyingly similar names. So an array, so both arrays and lists are used when we have a collection of variables of the same type. Usually when we've got multiple related items, but so for example, a list of heights for a number of flowers, or a list of flowers that we've made, or list of information. So each element on the list is one piece of information, and we have many pieces of information. Arrays, we declare an array by having like this. So if we want to say the type of an array, then we have the type of whatever the base type is, which can be any type we want, and then we put this pair of square brackets with nothing in it to say this is an array of that type. So this can be an array of floats by saying float and square brackets, or an array of game objects by saying game object and square brackets. It just means the things, this is a list or an array of things, and the things in it have the type float or the type game object or the type whatever they are. Usually a list has all the things on the list. Usually in a list or an array, all the things in the list or array have the same type. So that declares the array, but it doesn't actually allocate any space to put things in it, because we haven't said how many things we want. And we've just said, so this is like declaring a variable to be a float without saying what the value of the float is. And now we're declaring it to be a float array, but we haven't said how many things are in that array. So we haven't actually given it a value yet. So initially that's going to be null, which is, if you'll remember, is the nothing object. To allocate space, we need to say, we use the new command, and this is the syntax. We say new, and then whatever the type of the array is, and then in square brackets, whatever the number of elements are going to be in the array. Now this number could just be a straight out like numeral. We could put in 10 or 12 or whatever, or it could be another variable which gives us an integer. Any integer expression in here will do. So if we want an array of 100 things, we could say, we want an array of 100 floats, for example. We could say new float 100, or we could say new float 10 times 10, or we could say, we could have some other variable that has the value 100 in it, and we could say new float and then that variable name, or any other way of getting the value 100. So usually we'll actually either declare them with a fixed number in there, or else we'll declare them with a variable in which that variable we've already calculated what size we want the array to be. So we can calculate the size of the array at runtime and then create the array of that size if we want. So an example of that, so initially if we just declare h to be an array of floats, then initially h is just null. There's no space allocated to do anything. But as soon as we say h equals new float 4, then it creates room for 4 floats, each of which will be initialized to 0, because that's how, when you create a new float, that's how it's initialized. Now these are numbered from 0 up to 3. So this is h0, this is h1, h2, and h3. So each element of the array is an independent variable. They're just like any other variable you created. It's just that they're all named to have similar names. They're called h0, h1, h2, h3. But they're really just like any other float variable that you would have created, and you can stick whatever value in them. You can use them anywhere that you could use a normal variable. The way you access those variables is the name of the array, and then in square brackets the index of the entry that you want to work with. And the index starts at 0, and the biggest entry then is the size of the list minus 1. So here we had an array of 4 things, and they were labelled from 0 to 3. And we can access those using that sort of notation. So if we look at an example, if we create a new array of 4 things, then we can access this element 0 by using h0 with the 0 in square brackets, and just like any other variable we can assign a value to it, and it sticks the value in there, and all the rest of them are unaffected because they're completely independent variables. We can stick the value 2 into h1, and then we can read the values from h0 and h1 and add them together and stick them into h2, and so forth. So we can it's really just a way of creating a whole bunch of variables at the same time, and then using those variables based on their index rather than on their individual names. So we don't have to create 4 variables with different names. We can just create them all, one array of 4 things, and then look at those 4 things inside the array. We also have a length property, because often we might need to know later if we get an array that maybe it's not an array that we created, maybe it's an array that was passed to us from somewhere else. We need to know how long that array is. The length property tells us that. And so it's like any other property on an object. We use the dot notation to get at it, and so we say array name dot length, and that will give us how big the array is. So in this case, if we create an array of 5 floats, then if we print h.length, it'll print the number 5. So on an array, this property is read-only. So we said the difference between arrays and lists are arrays are fixed size. And so we can't do this. We can't set the length to a different value. That will cause an error. A very common thing that we do when we're using arrays, and we've seen it already in the code, is we iterate through every element of arrays doing the same thing on each element. And the standard way to do this is with a for loop, where we have our variable which iterates from 0, and it stops when it gets to the length of the array. So if we have an array of length 4, this will count from 0, 1, 2, 3. In other words, it'll iterate over each of the elements in the array. And we can do whatever we need to do to process each one. And so it may be, we want to print out each one, we can say print hi in here. If we want to, whatever operation we want to do on each one, we can do them in here, and the loop will make sure that we do it on every single entry in the array. So then lists are very similar to arrays. In fact, a lot of what you do, the code will look identical between lists and arrays. The difference is that lists you're able to change the length of a list. Whereas arrays, once you've created an array of 100 objects, it'll always have 100 objects in it. A list can be anywhere from an empty list with nothing in it at all, and you can add things and remove things and change its length. Lists are declared like you declare an object. In fact, lists are an object. They're an object of type array. And so you declare a list variable saying list colon array. So if you want an array of heights, you just say heights colon array. To create, like any other object, when you just declare it, its value is initially null. So it's the nothing object. To actually allocate space to start putting things into a list, we need to use new again. And in this case, we say new array and then empty parentheses there. We can also actually say new array and there are options to put entries in there, but it's generally a bad idea to do that. Normally when you create an array, you just create an empty array and then you'll add things to it and it'll automatically grow to whatever size you want, rather than creating a list that's of a certain size. So when you create an array, a built-in array, you'll dictate its size. When you create a list, you just create an empty list at the beginning and then you add things to it and it grows. It's really annoying that they've called them arrays. It's just confusing me. So in the same way as arrays have length, lists have length. So you can create a new list and then get the length property, and the length of that list will initially be 0. But unlike arrays, you can write to this. And if you change that variable, it'll change the length of the list. So if we set the length of the list to 3, we'll now have a list of 3 elements. Those elements will initially be null, but we can add values to them. So this gives us the ability to change the size of the list. Now if we have a list of 5 things and we set its length to 3, 2 things are going to be dropped off it, and the 2 things that are going to be lost are the 2 at the end of the list. If we have a list of length 3 and we turn it into a list of length 5, 2 extra entries are going to be added to the end, and those entries are going to be null. So sort of a neater way of creating a list, if you want to create a list of a certain size, is to first of all create an empty list and then explicitly set its length to whatever value you want. So if I want a list of length 3, I'll create an empty list like this and then I'll set its length to 3. and that will allocate the space for me. So there's a simple example of doing that. So we start off with an empty, start off just declaring it, and so it's initially null. We use the new operation in order to actually create the list, but there's nothing in it. Then we set its length to 4, and so it creates 4 entries in there, and those 4 entries are going to be null. Same way as with an array, lists can be list elements can be accessed using their index, and so we just can do exactly the same. This code is exactly the same as if it was an array. H0 is element 0 in the list, H1 is element 1, H2 is element 2. If we try to access an element that isn't there, so if we try to access if we have this list, this is H0, 1, 2, 3. If we try to access H4, we'd get an error because there is no H4 in this list. If we try to access H-1, we'd also get an error because we can't access elements to the left-hand side of the list. There's nothing there. But we can access, but the difference between lists and arrays is that lists have these extra methods on them which allow us to add and remove elements from the list. And depending on whether we want to add them at the beginning or the end, if we add them at the end, we use add. To add them at the beginning, we use unshift. And the reason, and to take them off the end, we use pop, and to take them off the beginning, we use shift. So interestingly, so what we end up doing is if you sometimes you use, actually I haven't got to think of it. So there are sometimes what we often use lists for is to remember things as they come up. In an example that I showed you in class before, we used a list to remember things that the player had clicked on and then to process them later. And what we were doing is we'd add things to the end of the list, but we'd remove things from the beginning of the list. So we'd be actually doing a queue. Every time a new thing comes in, it would go on the end of the queue, and every time we wanted to process one, we'd remove it off the beginning of the queue. And so that's called that's called first in, first out order. Got to get that right. FIFO, its general name. The other kind of thing you'll encounter often is what's called a stack, which is last in, last out. So it's like a pile of things. The last thing you put in is the first one you take off. And so in that case, if you're making a stack, you'd put things on at the end and then you'd pop them off at the end. And so the things are dealt with as the most recent things get dealt with first and the least recent things get dealt with last. That's really more than you need to be worried about thinking about. So if that didn't make sense, don't worry about it. But it's kind of useful to be able to use lists in this way. So finally, I think we're out of time. So often the question arises, which one should I use in my code? Basically, really, most of the time they're kind of interchangeable, and you could use either one. A lot of the time the code looks exactly the same, no matter which one you use anyway. But the difference is that arrays are fixed size and lists aren't. And so if we know in advance how many things we're dealing with, or at the time we create the array, we know how many things we're dealing with, then we'll use an array. Because if we get to a certain point and we're going to create the array and we know the array is going to contain 100 things, then we create an array. If we don't know at the time we create it how many things are going to come along, then we use a list. So for the example that I talked about previously, when we're collecting mouse clicks, we don't know, we're going to collect them in a list, but when we create the list, we don't know how many we're going to collect. And so we use a list. And we make that list initially empty, and then as mouse clicks happen, we can collect them in the list. If we knew that we were going to collect exactly 4 mouse clicks and that was all they were going to be, then we could use an array of length 4. But if we don't know how big it's going to eventually get, then we use a list. So arrays are generally simpler to use than lists, and so we use arrays unless we need to use a list. And we only need to use a list if we don't know how many things we're dealing with, is the usual case. But really, it doesn't matter. You could use a list if you wanted to. Underneath the surface, the list is probably implemented using an array anyway, but you don't need to worry about that. All right, so that's, all right, we're out of time. So in today's tute, you're going to be looking at that code that we had previously, and trying to use the source debugger, and hopefully it'll work better for you than it did for me. If it doesn't, then yeah, well, you know, that'll be fun. And then try to change that code to find the tallest flower and make it shrink rather than find the shortest flower and make it grow. Thank you all for coming. See you, some of you now, some of you next week.